Okay, we're going to take a look at equilibrium, which is always the first question on the AP test. Usually it's acid-base equilibrium, but it can be KSP. It can also be gas equilibrium or just plain solution equilibrium. Okay, so this was the 2011 question. They give you the fact that you have 3 beakers. One of them is 0.1 molar HCl, which is a strong acid. The other one's 0.1 molar NH3, which is a weak base. And the third beaker is 0.1 molar ammonium chloride, and you should recognize that the ammonium ion is the conjugate acid of the weak base NH3. So for the first part, you want to calculate the pH of the strong acid. So pH of a strong acid is the most straightforward situation. So you're just going to do this, and you'll get the pH is equal to 1. Okay, for the second part of the problem, you're going to be dealing with beaker 2, and they give you the reaction of what happens when you put ammonia in water. They just ask you to write the Kb expression. So that's also not so difficult, so we can do that. We're going to have the ammonium ion and the hydroxide ion and all of that over the concentration of NH3. Okay, so like so. And then they want to know the OH concentration in the solution. So we can do that as well. We'll just go ahead and put in the values there. So we know that the Kb is 1.8 times 10 to the negative 5th. We'll call this one x squared. That's an equal sign. And then that's going to be over the concentration of 0.1 molar. So basically what we'll do is we'll take 0.1, multiply it times 1.8 times 10 to the negative 5th, and that will give us 1.8 times 10 to the negative 6th. Then we'll take the square root of both sides. Okay, and when we do that, we're going to get that the OH concentration is equal to 1.3 times 10 to the negative 3rd. So in terms of the grading and the way that part works, let's see. So the expression would be a point, and this would be a point as well. Okay, now we move on to part C, and in part C they want to know what's going to happen in the reaction in beaker 3. So again, they give you the reaction, which is nice, and they want you to calculate the Ka for the ammonium ion. So you should recognize that as I said earlier, the ammonium ion is the conjugate of NH3. So we can say that Ka times Kb equals Kw, and Kw is 1 times 10 to the negative 14th. And just to sort of simplify things, we already knew that the Kb was 1.8 times 10 to the negative 5th, so that's going to give us a Ka of 5.6 times 10 to the negative 10th. Okay, and then they tell you that you're going to pour the contents of beaker 2 into the contents of beaker 3, or into beaker 3, and you want to know what's going to happen. So again, hopefully you recognize that this is a buffer situation, and you can say that the H plus concentration for a buffer is going to be equal to the Ka, which is 5.6 times 10 to the negative 10th, and that's going to equal the moles of the conjugate acid, or the weak acid, over the conjugate base. Now, these two number of moles are the same, so we could multiply it out, but we also know that they're equal. So you have 25 milliliters, and that's times 0.1 Okay, so that means the concentration, or the number of moles, of the NH4 plus is 0.0025. That was NH4 plus. And it's exactly the same concentration here. 25 moles ammonia. Okay, so what does that mean? It means the H concentration that cancels out, so the H concentration is equal to 5.6 times 10 to the negative 10th, and that's going to give us a pH of 9.25. Okay, so now we can deal with the last part of the reaction. So what we've done basically at this point is we've taken this solution and mixed it with this one. And we've said that what that's done is given us 0.0025 moles of ammonia. So I'll write it here, 0.0025 moles NH3 and 0.0025 moles of the ammonium ion. So now if we, this was a buffer, so now if we take the solution in beaker 1, so that's 0.0025 moles of a strong acid. So what's going to happen? So the acid, so here's the acid, and the acid's going to react with the base, and since you're adding equal moles of those two, you're going to neutralize. The acid and the base are going to cancel out. So you have 0.0025 and 0.0025, and those are going to react and give you 0.0025 here, but you're not going to have any of the acid or the base left, so it can no longer buffer. Okay, so now let's look at what happens in the last part of the problem. Okay, so we have the same sort of situation that we wrote. So we're adding H plus and NH3, and we're going to get NH4 plus. So let's use our ice table and see how that looks. So we're going to add 0.0025 here, 0.0025 here, but we already had 0.0025 of the ammonium ion. So this one's going to go down by 0.0025. This one's going to go down by 0.0025. This one's going to go up by 0.0025. So at equilibrium, we're not going to have any of this, none of this, and we'll have 0.0025 moles. And what's the total volume? So we had 25 milliliters of H plus, so that was 25 milliliters, and we had 25 there and 25 there, so altogether we had 75 milliliters. So we're going to divide that by 0.75 liters, and when we do, we'll get a final concentration of 0.0667 molar. Okay, so that was last year's problem.